Hey everybody, how you doing? We are going to do problems 1-38 to 1-41 together. You need to do problem 1-37 before you watch this video. Hopefully you did. Okay, 1-38 says measuring spread A. One way to measure the spread of data is to calculate the range. Okay, so range equals maximum minus the minimum. You guys probably already knew that. What range of cell sizes did each sugar grow? Why is the range not often a useful measure of spread? Okay, so we have sugar W and sugar P. The range of sugar W, the highest value was 70, the lowest value was 10. And I believe it's exactly the same thing for sugar P. Okay, and these are micrometers. Okay, so the question also asked, why is the range not a useful measure of spread? Well, that's because the only calculations you're using are the extreme ones. There's no indication of how many values there are or where the data is located. Is it toward the bottom? Is it toward the top? You don't know. All you know is how far apart it is. So you're only using extremes and not taking into account any of the data in the middle. Which is usually where most of it lies. Okay, we are actually going to skip B and C because I don't need to teach you mean absolute deviation. I've never seen that on the AP test. It's just a CPM thing. When the data is not symmetric or has outliers, the interquartile range IQR can be used to measure spread. Compare the IQR of the two sugars. If you need a reminder, read the math notes box about calculating IQR at the end of lesson 1.2.1. Or you could just wait a second for me to tell you what IQR is. And you guys already might know this. So IQR stands for interquartile range. And what it is the middle 50%. See how this would be a better measure of spread than the range itself, because this is just the extreme values. This takes into account the middle 50%. And we calculate that by doing quartile 3 minus quartile 1. And so between quartile 3 and the median is 25% of the values, and between the median and quartile 1 is 25% of the values. So together that makes the middle 50% of the values. Okay, so for sugar W, I have already entered my values into my calculator, and you guys remember my document camera doesn't love the calculator, so we'll see how it goes. One variable stats. I'm gonna do L1 first. Come on, document camera, you can do it. Okay. Still not focused. Alright. I'm so sorry. You guys are super patient. Okay. So I ran one variable stat. I'm just kidding. Okay. And to find the quartiles, you scroll down. Hopefully you guys well, this is a good reason for you to do it on your own and not just use the video, but you can see hopefully that quartile 1 is 34 and quartile 3 is 45. You can see it for a fleeting second. Okay. So this is for sugar W. Quartile 3 is 45. Quartile 1 is 34. 45 minus 34 is 11. Make sure to always put your units on. Okay, now I'm going to run it again for L2. And to remind you, if you want to put L2, you can put second 2 real quick before the document camera realizes that you're there. Okay, scroll down. Alright, so Q3 is 55 and Q1 is 25. Okay, and what does this mean? Sugar P is more spread out, so sugar W is more consistent. Okay, 39. Okay, you're going to be very happy we're doing this one together. Statisticians prefer to make numbers positive by squaring them instead of using the absolute value. From algebra, you know the inverse function of a square root is a quadratic. Okay, hopefully you know that. Quadratics are relatively easy to work with in higher mathematics, while the inverse of an absolute value function cannot be expressed as a function at all, which causes complications. I probably just lost you in there. That's okay. The variance is a measure of how much variability there is in a data set. The variance is the average of all distances to the mean after the distances have been made positive by squaring. The standard deviation is yet another measure of how much variability there is in a data set. The standard deviation is simply the square root of the variance. What advantage is there in reporting the standard deviation instead of the variance? Okay, so we're going to do a couple of things here. We're going to put the formulas down and then we're going to put the advantage. So let me scroll down and make sure. Okay, so the variance doesn't really have a fancy symbol. People write var equals sigma. This is the sum of all of the values minus the mean squared divided by however many there are. Let me say that again. The variance is the sum of all of the values minus the mean squared divided by however many there are. And the standard deviation, which we call sigma, is the square root of the variance. So we are going to find this and then take the square root to find the variance. Okay, as you can tell what's coming in number 40, we are going to have to actually do this with the sugars. I'm going to do sugar W and you guys will need to do sugar P. And then I'm going to show you how to do it on a calculator. Okay, the other thing it says is the standard deviation is simply the square root of the variance. What advantage is there in reporting the standard deviation instead of the variance? Well, the reason is because when you square the values, you're no longer in the same units. So the standard deviation is in the same units as the mean or the values. So in micrometers here, if we're working with this, I calculate the variance, that would be in micrometers squared, which is not really great for comparison purposes, but then when I square root it, I get it back to micrometers. Okay, so make sure you guys have some room, because we're going to do this by hand, and we're only going to do this by hand for number 40. We don't do this by hand really ever again in the school year, except there is one lesson where you use this process to do something else, and that is going to come up in chapter 2. But for the rest of the time, you'll be able to do use the calculator for this. Okay, the first thing that you want to do when you calculate the standard deviation, so we're going to do the variance first, and I'm going to do sugar W, and you guys are going to have to do sugar P on your own. Step 1 is to find the mean, and in this case it was 40. The mean is also 40 for sugar P. Okay, this is the part where it gets tedious. The next part, so we have this value. The next thing we need to do is take all of our values for sugar W and subtract the mean. Okay, so I'm going to list them here. I have 10 minus 40. You see where this is going. 32 minus 40. 32 minus 40. 34 minus 40. 34 minus 40. 36 minus 40. 37 minus 40. 2 39s. 40. At least that calculation will be simple. Okay. 41 minus 40. Leave some space here. 43. 43. 44. 45. 2 46s. 49 and 70. Oh, well, that's super unsatisfying. 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. Did I miss one? 1, 2, 3. No? Okay. Alright. And then we're going to take those values and square them. We have really good mental math skills. I'm pretty sure that we can do this in our head. Okay. Alright. So, 10 minus 40 is 30. 30 squared is 900. Let me just check. It's like a math test when you check what everything is. Okay, so this is 8. 8 squared is 64. 64. 6 squared is 36. 36. 4 squared is 16. 9. 1. 1. 0. 1. 9. 9. 16. 25. 36, 36, 81, 900. Okay. Then what you're going to do is add all of those up and divide by however many there are. So right now we have each value minus the mean. We've squared it, and now we're going to do the sum part. This big capital sigma means sum, so we're going to add them all together. So 900 plus 64 plus 64, 36 plus 36 plus 16 plus 9 plus 1 plus 1 plus 1 plus 9 plus 9 plus 16 plus 25 plus 6 plus 36 plus 81 plus 900. 2240 divided by how many numbers there are? 19 equals 117.8947, and this is micrometers squared. Okay, so step 1, step 2, step 3, and step 4 is just to take the square root Some of you at this point might be wondering what to round to. I usually do 4 decimal places. It really depends on the math problem. This is the good news. There are no such thing as sig figs in statistics. So you do need to use kind of common sense precision, but I've never seen College Board take points off for rounding. I think I'm pickier than the College Board is, actually. Okay, so sigma equals 10.8579. Okay, and you guys are going to have to do sugar P over here. Hopefully you have enough room. Very sorry that I took all that room. Hopefully you don't write as huge as me. That would probably be good. Okay. Now, number 41. This is the last one I want to do. And number 41 is really just a demo, so I'm going to just put it down here. You guys already know how to do this, most likely. If you could see it on my screen, that would be amazing. What I'm going to do is that one variable stats again. Ask the calculator to focus. Okay, so I want you guys to see that sigma x is right here, 10.8579, and I got 10.8579. Notice it took the calculator 1 second or less to do it. It took me like 4 minutes. So that's why we won't be doing this process pretty much ever. We will be using the graphing calculator to find it. But please calculate it by hand for sugar P just to make sure you know how to do it, and then check your answer with one variable stats for L2 to finish problem 41. And then always put your units, and I'm going to put check with one variable stats, and I want to look at sigma x. Okay, just a little warning before I stop the video. There are 2 different types of standard deviation. The chapter will get into this, but you can see them on your calculator here. This is the one we just calculated. This is called the population standard deviation. And then the one above it that says S, a big S. Oh, do I need a new document camera? I don't know. That says big S equals 11.15, whatever. Hopefully you saw it. It's right above the one that has the lowercase sigma. That one is for the sample. Sample starts with S, so it's got a big S. And there's a difference with that, which I will explain to you in a later video. But for now, we're going to use the sigma and compare that with your calculations here. Thank you, everybody. Have a great day.